Hello and welcome to Workshop 4 today. I am JD Crumney. I'll be running today's workshop for 3D printing. Alright, let's get started. So today we will discuss how to use more tools in Google SketchUp that will be helpful in completing your 3D models for CSIM Challenge. So the first tool I want to talk about is a very important tool, and this is the Dimension tool, which will allow you to draw lines between any 2 points, and when you draw the lines, it tells you the dimension, the length of the line. So using this tool is critical for checking to make sure that your dimensions meet the dimensions of your model meet the dimension specifications for your CSIM Challenge category. Because if you remember, the dimensions used in Google SketchUp are the real world dimensions. So when it goes to 3D printer, that's the size the 3D printer is going to print. Now, after selecting the Dimension tool, you click on any 2 points to find the distance between them projected onto several orientations. So you can find the distance along the x-axis, the y-axis, or the z-axis between any 2 points. Or if you just want the actual distance between the points, then you can just do a straight line distance. You can also click on the perimeter of a circle, and once you do that, it'll give you the diameter. And so, or you can click on a line or an edge, and it'll automatically give you the length of that line. So you don't have to go between the endpoints. It'll just say if you click on the line, it'll tell you the length of the line. The dimensions will be given in whatever units that the SketchUp model is set to. So if you chose to use the feet and inches template when you open SketchUp Make and start building your model, then the dimension that it'll show you will be in feet and inches. Or if you use meters and millimeters, then the dimensions will be in meters and millimeters. Now here we're talking about the protractor tool, which measures angles and creates guides so that you can, if you want to design a certain curved side, you can use this to keep track of the angle of the curvature. So after you select the protractor tool, you must click on whatever point is the vertex of the angle that you want to measure, and next you choose the direction of the first ray that serves as the one of the 2 rays that form the angle at the vertex. So you click in any direction, and that'll be the direction of the first side. And then you create a guideline that is in the direction of the second ray of the angle by clicking somewhere in the direction of the second ray. And you'll notice that if you look down on your screen to where the measurements tool text box is, that as you're changing the size of the angle by changing the direction of the guideline that you create, it'll actually tell you what the angle size is. Or you could, the same way with making a line, if you are moving the line and then you click in the measurements box and actually type in an angle, it'll make your guideline that angle relative to the first ray. Alright, next we'll talk about the rotate tool, which works very similarly to the protractor tool, except this tool will actually rotate, stretch, or copy and array selected entities in the orientation that you choose. So instead of just measuring an angle, it'll actually turn something about whatever angle you choose. So to use the rotate tool, first you got to select the entity that you want to rotate, and then you select the rotate tool and select the point about which the entity to rotate. You select the point about which your entity will be rotated by clicking on any point. So if you want it to rotate about its central axis, you just click somewhere along the central axis, and that'll be the rotation point. Next, you create a guideline between the point that you just created and the some arbitrary point by just clicking in the arbitrary direction. And then as you move your mouse after creating this guideline, you'll notice that the object is rotating along with the guideline. And then once you click again, you'll just place your object in the new orientation. Now I realize that understanding the rotation tool is a lot easier to see than it is to explain, so I have a link here to a video that'll give you a real good demonstration of how to use the rotate tool. So we're going to check that out now.
Let's explore the Rotate tool using some examples to illustrate how it works. Take a moment to understand the concepts and steps we'll take with this example. When you pick the Rotate tool, the icon orients itself to any surface you hover over, and you click your mouse button once to set the rotation center and orientation. Then you move your mouse away to establish a rotation arm or base. Click again to set this base. Now, as you move your mouse around, you are rotating the object based on the point and orientation you chose. The usefulness of the rotation arm you set is the ability to rotate precisely to other geometry. Click to finish, and that is how the rotate tool works. Now, let's show some real examples. What if you wanted to rotate the different hands of a clock? Select the hand you want to rotate first, then choose the rotate tool and move it to the center of the clock. Click here to set the rotation center. Move to the end of the hand and click to establish a meaningful rotation arm. And now you can rotate the hand to any position you need. Click to finish. Now, let's try a new example. We'd like to rotate this vault door into an open position. Select the door, then move the rotate tool to the door hinges. We may need to zoom in to properly place the rotation center. Simply roll your scroll wheel forward to zoom in and out as needed. Now, place your rotation arm. In this example, we don't need to move from anywhere specific on the door, but simply picking a direction parallel to the door will work fine. Now, rotate the door outward and click to finish. Now that you understand how to use the rotate tool, here are some additional tips. You can lock the rotate orientation in any direction by holding the Shift key. Hover over a surface or in a plane that you want to lock the rotation to. Hold the Shift key, and now as you move around, the rotate tool no longer orients to each surface, but remains locked in one orientation. In our clock example, if there was a center cone, it would be difficult to establish the correct orientation. But by locking the orientation, we can easily use the rotate tool as needed. You can also define the orientation by dragging your mouse button. Say we wanted to fold this surface up like a paper airplane. Click and drag the mouse from this center point, and you can see by dragging around, you can choose any orientation. Set the orientation you need, which for us is along this fold edge. Now proceed to rotate the surfaces up into the plane shape. Repeat this process to complete the paper airplane. Although you will usually want to pre-select the objects you need to rotate, you can in fact auto-select objects to rotate. Make sure nothing is selected, and as you hover around your screen, you can see entities are auto-selected, and you can use the rotate tool as needed. Finally, you can rotate copies and arrays using the rotate tool. This topic is covered in depth in another video, so for more information, view the video on copies and arrays.
Okay, the video is complete, so now we'll continue with the presentation. So the next tool I want to talk about is the 3D text tool. This tool allows you to draw 3D text, and the way it works is after you select the tool, you type the text and choose settings for the text such as the font and the size in the text box in the box that appears. Then you click the place button inside that box and the 3D text will appear. Now I figured this would be very useful for the where you have to create the label for your solution for the C-STEM challenge. 3D text would be very helpful for creating that. The next one is the offset tool. This tool allows you to offset selected edges in a plane. So after you select the offset tool, you click on some face whose edges you want to offset, and then you move the mouse to select the offset distance for the offset edges and click again to create the offset edges. So once you click the face, you'll click some certain distance either inside or outside of the face, and it'll offset the edges of the face whatever distance you click at. The next tool is the scale tool. This tool allows you to scale and stretch selected entities. So after you select this tool, clicking on an object will allow you to edit the object size in various ways. So after you've created your entire object, the scale tool will be very useful in changing its size without having to actually redraw edges over and over again. Next is the arc tool. This tool allows you to draw arcs from point to point with a bulge. So after you select the tool, you draw a line from point to point the same way you do with the line tool, but then you move the mouse to choose the radius of curvature of the arc, and you click again to finish the arc. Now I want to talk about something important also, and that was came to my mind when I was sending out the email. So 2 weeks ago, an email was sent out informing all the lead teachers for CSTEM Challenge competitions involving 3D printing that the deadline for submitting the 3D models for geoscience, sculpture, and robotics competitions has been changed from Tuesday, March 25th to Monday, March 10th of 2014. Now, as I said, I sent this email out a couple weeks ago, but there were issues when I was sending it, and the server kept saying that it was sending it back to me, and I wasn't able to confirm whether or not everyone had received the email. So now I'm trying to make sure that everyone gets the notice that the submissions will now be due no later than March 10th. Additionally, on that same day, I sent another email out that invited all the lead teachers for the CSTEM Challenge competitions involving 3D printing to a folder at www.dropbox.com entitled 2014 CSTEM Challenge 3D Printing Submissions. This folder is where all the 3D model designs will be submitted to CSTEM for printing. So this is where you'll submit your final model by March 10th. Now, if you do not receive this email, please send an email to my address at techadmin@cstem.org immediately so that I can send the invitation to you right away. That way you'll be able to submit your 3D models once you're ready. You'll also find a document containing an information sheet for 3D printing within the folder mentioned above. So once I send you the invite and you get access to the folder, you will see a document that is a 3D printing information sheet, and that gives a lot of details that will probably answer any questions you have about 3D printing that might not be clear just yet. Alright, well, that's all I have for today. Thank you for attending, and if you have any questions, you can chat with me live on CSTEM Break right now at the end of the video. Otherwise, you can contact me via email at techadmin@cstem.org. So I will see you again for Workshop 5 on March 29th. Have a good day.